Imagine spraying your kitchen counter with a fresh lemon-scented cleaner. In just a few seconds, grease disappears, fingerprints vanish, and the surface shines like new. But have you ever wondered what it really takes to create that simple bottle sitting under your sink? Behind every spray hides an extraordinary journey through chemistry, engineering, and massive factories that never seem to sleep. Most people never think about this, but a single cleaning spray contains carefully balanced ingredients measured down to tiny fractions of a gram. Too much of one chemical and it could damage surfaces. Too little, and it simply won't clean. What happens next surprised even experienced engineers. The journey begins thousands of kilometers before the factory. Many surfactants, the ingredients that lift dirt and grease, start with natural oils from Malaysia and Indonesia, where vast palm plantations supply the raw materials. Others come from petroleum-based feedstocks refined in modern chemical plants across the United States, Europe, and the Middle East. Every shipment undergoes strict purity checks before it can enter production. Water makes up the largest part of many cleaning sprays, but not just any water. Massive purification systems remove minerals, bacteria, and microscopic particles until the water reaches extremely high purity. Without this step, the final product could lose effectiveness or even become cloudy after only a few weeks on store shelves. Fragrances travel an equally fascinating path. Fresh lemon notes may come from citrus oils extracted around the Mediterranean, while floral scents often begin in advanced fragrance laboratories where scientists blend dozens of aromatic compounds into a single signature smell. Just a tiny amount can transform an ordinary cleaner into a product people instantly recognize. The plastic bottle has its own remarkable story. Tiny polyethylene pellets arrive by truck or rail after being produced in giant petrochemical facilities. They look like ordinary white beads, but each one will soon melt and become a perfectly shaped spray bottle capable of surviving thousands of squeezes without cracking. Even the spray trigger demand precision. Tiny springs, seals, valves, and plastic parts arrive from specialized manufacturers before automated assembly lines combine them into a mechanism that delivers a fine, even mist every single time. A single faulty component could ruin the entire bottle. By now, every ingredient has traveled an incredible journey across oceans, highways, and laboratories before finally meeting inside one factory. But here's what nobody tells you. The real magic hasn't even started yet. In the next stage, giant stainless steel mixing tanks will transform these ordinary ingredients into millions of bottles of cleaning spray every year, and the process is far more impressive than most people could ever imagine. Now the real transformation begins. Thousands of liters of purified water rush into giant stainless steel mixing tanks, each capable of holding more than 10,000 liters. Computer-controlled valves open with perfect timing, and the factory fills with a steady hum of pumps and motors. Every ingredient must enter the tank in the correct order, or the entire batch could fail. Next come the surfactants, the cleaning agents that break apart grease and stubborn dirt. Powerful mixers spin at around 100 to 300 revolutions per minute, blending the ingredients for 20 to 40 minutes. The liquid slowly changes from crystal clear to a smooth, uniform solution, while sensors constantly monitor temperature at around 25 to 35 degrees Celsius, keeping every batch perfectly stable. Once the base formula is ready, fragrances, dyes, and preservatives enter the mixture in tiny but carefully measured amounts. The scent of fresh lemon or cool lavender quickly spreads through the blending room. Imagine standing there as a clean, refreshing aroma fills the air while computers adjust every measurement down to the last drop. Before filling begins, technicians collect samples from every batch. They check the pH level, viscosity, color, and cleaning performance to make sure the formula meets strict quality standards. If even one result falls outside the approved range, the entire batch stops immediately for correction. That's how factories protect millions of customers every single day. Meanwhile, empty plastic bottles race along automated conveyor belts at speeds of up to 250 bottles per minute. High-speed filling machines dispense the exact amount of liquid into each bottle within seconds. Precision nozzles prevent spills, keeping the production line fast, clean, and incredibly efficient. The bottles move directly to another automated station where robotic arms attach the spray triggers and tighten them with perfect force. Every click you hear means another bottle is sealed and ready for use. Laser sensors instantly detect missing caps or loose fittings, removing defective bottles before they continue down the line. Finally, colorful labels wrap around each bottle before groups of finished sprays are packed into cardboard cartons by robotic palletizers. Within just a few hours, raw chemicals have become a product trusted in homes around the world. But here's the surprising part. Even now, the factory isn't finished. Every single bottle must survive a series of demanding quality tests before it ever leaves the building. The factory now hands control to advanced technology. AI-powered cameras inspect every bottle at incredible speed, checking the fill level, label position, and spray trigger alignment in just a fraction of a second. Most people never realize that a tiny defect invisible to the human eye can stop a bottle from reaching store shelves. VV. Next comes a pressure test. Random bottles are sprayed hundreds of times to ensure the trigger never jams or leaks. Others are dropped from different heights and exposed to hot and cold temperatures, proving they can survive real-life use without breaking. But here's where human skill still beats machines. Experienced quality inspectors pick up random bottles and check the spray pattern, fragrance, and overall finish by hand. Years of experience allow them to notice tiny imperfections that even advanced sensors can occasionally miss. Only after passing every inspection does each bottle earn approval for shipping around the world. From a handful of raw ingredients to a perfectly engineered cleaning spray, the journey has been nothing short of extraordinary. But one question remains: just how many of these bottles are produced every year? The answer is almost impossible to believe. Cleaning sprays have become an essential product in homes, hospitals, schools, and workplaces across the globe. Every year, manufacturers produce billions of bottles, supplying a global market worth tens of billions of dollars. The United States, China, Germany, Japan, and the United Kingdom rank among the world's largest producers and consumers of household cleaning products. Did you know that many modern factories now use recycled plastic to manufacture new bottles? Advanced production lines also reduce water and energy consumption, making the industry cleaner and more sustainable than ever before. What once relied almost entirely on manual labor is now powered by robotics, artificial intelligence, and smart automation. From carefully selected raw materials to precision manufacturing and strict quality control, every bottle follows an incredible journey before it reaches your home. The next time you clean a window, countertop, or table, you'll know there's an entire world of science and engineering behind every single spray. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by science, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.